Hey everyone, sorry for starting late. I had challenges with my ISP, and then just before that, OBS also gave me a few challenges, so I was trying to reset a few things. So let me make sure everything is working. I need to confirm that my audio and video are working fine. Chain of thought, thank you for waiting. I hope you're doing okay. Let me adjust my... Okay, I think this is good enough. All right, let's get started. Okay, so today we're going to deal with deploying using the CI/CD, okay, pipeline that is going to help us to deploy using GitHub Actions to AWS EKS. Okay, yeah. So I think my audio is okay. In case anything happens, like a drop off or my network gets stubborn, please let me know. I will be alert to look at the charts and everything. All right. I hope you're having a good morning, a good afternoon, a good evening, maybe even a good night, okay? Depending on where you're watching this from. I want us to have a successful session. And yeah, sorry for beginning late. So let's go to, I'll take you to AWS first of all. I think that's the most, I think, natural place I should take you. So you can see my AWS here. This is, let me zoom in a little bit. So this is the Amazon Elastic Kubernetes service that people call EKS. Okay, there is no cluster, like you can see. Okay, it says no clusters. You do not have any clusters. It says create cluster. Of course, I'm not going to manually create the cluster. I am going to we're going to automate it. Okay, and you're going to see how it's done using GitHub Actions, and I'll explain to you the whole workflow. It's actually similar to the workflows, the workflow we built for the compose, the current production. You're going to see it. It's quite similar. It's the same. And I would say nothing complex concerning it. So let me go ahead and show you the pains I was going through yesterday. Yesterday I had something very small that actually disturbed me. And it was only concerning the Redis URL. In my head, I thought I'm still using compose. Okay. For some reason, I forgot that. Okay. So Redis was pinging localhost instead of pinging the Amazon Elastic Cache. Yeah. So I tried and tried and tried, got tired and rested. Then later, when I was chilling, I remembered. So you see, I had a failing. I see this one here down here. It was failing. But even then, the others which were failing, which are just not being shown here. Okay. But let's go through this. Okay. So I have two workflows, okay, two main workflows. One is called provision, the staging infrastructure. This will be done once, okay? And we have the deploy backend to EKS staging, okay? Then we have the Terraform CI/CD. This is the old one, okay? And now I discovered this is a very bad name I gave. You shouldn't have named it Terraform CI/CD. That shows you I was also in my early stages, okay? I should have given it a better name, okay? So we have deploy back into EKS staging, and we have provision EKS staging. And I'm going to show you, explain to you everything, okay? So that you learn and understand what is going on. When you look at this, let me zoom in a little bit. See, it says this workflow has a workflow dispatch event trigger. This simply means that we have a button right here, which enables us to start this workflow manually, okay, if you want to. So it's supposed to be automated, but you can start it manually. For example, I can come and click, okay, and let me zoom out a little bit so that you see the button. You see, it allows me to choose the branch, okay. Then I can either apply. The apply would mean I am creating the infrastructure. Destroy would mean I am destroying the infrastructure. So I can do it from the UI here, okay, or I can do it from my terminal manually. or I can edit a file, push to GitHub, and something can happen. You get, yeah, and it will be automatic every time you push to GitHub. And I'll show you the rules in a moment, how pushing to GitHub will trigger this. Okay, yeah. So being developers, maybe I know being developers, we like working with the CLI. Personally, I like working with the CLI. I will show you how this happens, how we have this apply and destroy button, but you can also do it from the terminal. Okay, so I need to look for my VS Code. So here, this is VS Code. Okay, to do it from the terminal is also very easy. Actually, creating the provisioning the infrastructure on EKS takes some time. Okay, takes some time. So it is wise that I do it right now. Okay, and the command to do it, you need the GitHub CLI. Okay, using that tool called GH. Let me put it in terminal. Then close this. Maybe clear here. No, I meant the terminal instead. What's happening? Okay, awesome. Now it is called, the tool is called GH. Okay, it's called GH. But to install it, you simply come here. Okay, GH. You simply go it, and you come here. You see, they say take GitHub to the command line. Okay, it's simply a command line tool for GitHub, and you can, if you like, on Mac like me, you can use brew install gh to install it. Okay, and you can click on this button to see your other platform. If you're on Windows, Linux, okay, other options for macOS and Windows, okay, Linux, okay, depends on your platform, but it's very simple to install. So I installed this command line tool, okay, called gh, and using gh I'm going to trigger that workflow. So I'm going to trigger it, okay, the provisioning of the infrastructure, and we are going to go, you'll see the UI that it's set automatically being deployed. Okay, so there are three ways you can do it: by doing a git push, which I assume everybody at this point who's following this playlist knows how to do a git push. Okay, that will automatically run a workflow, but also we're going to either use this button to destroy it manually or apply it manually, or use the GH in the CLI. So I'll show you the things that are not obvious to this project. So I'll start with GH, the pressure, okay, of the, can I call it the infrastructure? All right. So I'm looking at my notes to make sure that I'm following the exact order of what I wanted to do today. So I'll say GH workflow. Okay. So GH is the CLI tool. Okay. Then workflow is the workflow, means the command that's going to work on a workflow. Then I'll say run. Okay. Then we want to run Terraform. Okay. Dash Kubernetes. Kubernetes. This is the name of the workflow. If you come here, okay, it is right here. You get. In fact, I can just come here, okay, and copy this name, this whole name. I think we give it the same name. In fact, if you go inside here, okay, and you go to the top, you'll see that we have some things here, okay, and I'll explain to you everything that is in this file. So gh workflow, okay, meaning we want to run a workflow. Then we say run, okay, then mention the name of the workflow. After that, I simply specify the repository. Okay, I'll say minus minus repo will be kne / arrow. I think is lowercase, if I'm not mistaken. Arrow bound ventures. Okay, let me check. Let me check. It has underscores actually. Yeah, underscores. Arrow bound ventures. Okay. Then minus ref. Okay. We say it is the main repository. Then minus f operation, okay, is equals to apply, because we are creating the infrastructure, and you're going to understand in a moment why we are doing this. So you see, it has created the workflow, okay, and we have the workflow ID here. You get this value here you're seeing is the workflow ID, this ID here, okay. If I go back to GitHub, are you seeing provision EKS staging, okay, is now running, okay? It has been triggered, okay? Again, we shall trigger it automatically by simply doing a git push, okay? I expect you to do the same thing. So you see, everything is what? Being created, okay? But also in our terminal, we can watch the same thing, okay? I can come here, copy this workflow ID, okay? And say gh run watch, okay? Watch, we paste in the infra ID and say minus minus repo. I copy this other repository from up here. Where is it? Just to save time, I copy this repo name, paste it, okay? Then after that, I can say minus minus exit dash status so that we know the exit status at the end. Says cannot command venture is not found. Okay, let's fix that. I need to, okay, do that. Then hit enter. So you see our terminal changes and you see we have a few things going on, okay? So setting up the job has been successful. Check out repository successful. Configure infrastructure has been successful. Set up Terraform successful. Initialize Terraform successful. Check Terraform formatting successful, okay? Validate, okay? We are waiting for these others to also be successful. So this is how you can watch from your terminal, okay? You can decide to watch from your terminal or you can go to your UI, okay? So you see here, if I minimize all this, you see, none of them have passed, okay? And it is still running, okay? It is trying to create the infrastructure and trust me, it takes some time, okay? That is why I wanted it to happen earlier in this stream, okay? But if I minimize these others, you can see that other things succeeded, okay? We have, you see, we have ticks on this, okay? So we are on applying staging infrastructure. So you can have it right here in your UI and monitor it from the UI or right from here in your terminal using the watch command. So for those of you who are using the public repository, simply with the commands I've used, replace my repository name with that public repository. Replace the infra ID with your infra ID. Okay, and there's so many other things I'm going to show you. So I wanted us to get that out of the way to have the infra being created. Okay, actually, if I go to AWS here, okay, and I refresh, you see, right now it says you don't have any clusters. If I refresh, okay, I see we have an infrastructure being created called error backend staging, like we had planned, and it is in a status of creating. Okay, you see the creating, it is in status of creating. That's shown as our Kubernetes version. Okay, support period is here. Okay, I see. When was it created? 3 minutes away. Okay, 3 minutes ago. Why did I say away? I'm allowing my mother tongue infiltrate English. So 3 minutes ago, and then our provider is EKS. I see. That's awesome. Now, let's go and understand how this is possible. So to understand how this is possible, I'll take you back right here. Okay, so as we are watching, I'll leave this terminal and I take you to the workflow that handles this. Okay, the YAML that handles this, and it is this file. Okay, so I think, in fact, I'll minimize all this. Okay, let's start from the top. So name says provision EKS staging infrastructure. That is the name you're seeing here on GitHub Actions. I see this name here. Not that one. Let me open a new tab. Oh, actually, it's right here. I see this at the top. This one here, provision EKS staging infrastructure. Okay, that is the name of the workflow. I can delete this. Okay, then on we have now the workflow dispatch. So workflow dispatch, like I told you, is what helps us, okay, to manually trigger our workflow, okay, and it creates this button, okay, like I showed you earlier. Let me undo this. and come back. Let me go to here. Okay, I'm using this button here, run workflow. Okay, with apply and destroy. It's what helps us to do that. Okay, so those options called apply and destroy are what you're seeing on this line here, line 12 and line 13. Apply and destroy. And you see, it's of a type choice, meaning you can choose between two things, and the options are apply and destroy. The default value is apply, you get, and required is true. Okay, meaning you cannot trigger the workflow without choosing an option. Okay, and then this is simply its description. Okay, so you have workflow dispatch. Okay, and it takes in inputs. Okay, and now inputs you have a particular operation. Okay, and in that operation you define its description, you define that it's either required or not. Okay, you define the default operation, which is first apply in this case. Okay, that is why when you go to the UI, you see that apply is chosen by default. Then you have the options of apply and destroy. When you go to the UI, here you also see apply and destroy. So all this, okay, let me zoom out a little bit. All this from line 4 to line 13 helps you create that manual trigger button. Okay, and I created to enable me destroy the infrastructure. Okay, after I've created it, just to minimize costs. Okay, because I'm just using it for the staging environment. So I'll close that. Then go to the next section of push. So it says when we push, okay, when is this workflow triggered? Okay, it is triggered manually using workflow dispatch, or let me minimize this, or when we do a push, a git push, or when we do a pull request. So I'll leave you guys to in your forks, okay? Because I see many of you have forked the repo. In your forks, do a git push, do a pull request, okay? And see everything happening. So on push and pull request, or manually using workflow dispatch, we can trigger this workflow. So on push, you have a number of rules that it only applies to the main branch, okay? And it only applies to the Terraform Kubernetes staging directory if there's a change to this directory, okay, or a change to the Helm backend secrets, because remember, Helm backend secrets is going to help us install the Doppler operator, okay, which is kind of like an infrastructure task. Then if the workflow file itself changes, you get. So we have these three. Awesome. Then for the pull request, we have the same rules, okay. It should be triggered only on the main branch if the changes are on the main branch, and if the directories or the files are in these directories or this file. Then we go to the permissions. So in permissions, content simply allows, okay, the GitHub action to read the contents of this repository. Then ID token write simply allows GitHub Actions to request a temporary OIDC token, okay, for authentication with AWS. Then we have the concurrency block, okay. So concurrency simply is setting up rules, okay, for what happens when two workflows are trying to manipulate our infrastructure simultaneously. So in this case, we are trying to prevent them, okay. So on line 34, we say we have group. So group simply puts all workflows, okay, under this same name, okay, puts them under one name. And then on line 35, we have cancel in progress false, meaning that if you have one workflow that has been triggered and it's running, then you have another workflow start, you get. In that case, what happens is that the first one must finish before the second one starts. The one which is in progress is not cancelled. As simple as that. The one that is running in progress is not cancelled. It finishes until the second one. Otherwise, if this is true, and then there's one workflow running, and then you trigger the second one, the first one will be cancelled and the second one will run. And because we're touching infrastructure, we don't want issues, okay? So cancel in progress will be false. Then we have the env. Okay, so these are just initial initial environment variables that we need for our infrastructure creation to create, okay? Like the AWS region, okay? Saying that to tell Terraform that this is happening in a CI, okay? It's an automation process, okay? The EKS cluster name, the Kubernetes namespace, okay? To create the infrastructure config map, okay? It's called backend infrastructure. And I'm going to explain to you why. Actually, I touched on it earlier because I told you I was dealing with an error, okay? And the error was that in my Doppler secrets, I had Redis pointing to localhost in compose. And it was an issue because on EKS, it was expecting the elastic catch URL. So what I did was to create a config map, okay, that pushes or that creates that Redis URL, and you're going to see it, okay? But this is simply the name of the config map, just like we have a name of the secret. Then the Doppler operator namespace is Doppler operator system. The project is FastAPI backend. This is the Doppler project, and the config is STG, meaning staging. So those are environment variables. Then we can now go to the jobs. So in the jobs, we have one job called Terraform, okay? I know I'm terrible at naming, but you can give it anything, okay? So the first one here, it says plan or apply staging infrastructure, okay? And it says if the GitHub repository, okay, is this, okay, then run on this machine, provision a Ubuntu latest machine, okay? So if you are working on the GitHub mirror, okay, this is what you have to do. You have to change this, okay, to maybe Airbound Ventures public or to whatever your fork is, okay? Understand that. So once you are done having the infrastructure, okay, our machine, which will be a Ubuntu latest machine, then we go to the next here, the steps, okay? So in the steps, we have checking out the repository, okay, which is here. Simply uses an existing actions checkout at v6, which will download our code into this machine. Then we have the next one, configure infrastructure, okay, which is simply configuring the AWS credentials, okay, and uses an existing action, says AWS actions, configure AWS credentials, okay. So this does the OAIC, the thing that I told you about, okay. We give it a role to assume, okay. This is the role to assume we put in the GitHub secrets, okay. Let me show you that quickly. Yeah, my machine is now hanging, okay. I have so many things running. I'm learning the hard way. Actually, I checked and my swap memory was a lot. Okay, maybe 10 GB in swap. I'll have to close a few things. Wow, it can't allow me even do what I want to do. I think this cursor can't change to the pointer. Help me go to settings. It's well. Let's continue before it crashes out. All right, so the role to assume again comes from secrets. AWS role to assume. This is what we created in the previous tutorial. And I'll show you, okay, when I cancel a few processes. Then the region, okay, comes from our environment variable up here, okay. This one on line 37. Then the role session, this is a name for the session. Can be anything, okay. Doesn't have a big impact. Simply think of it as a label. Then I'll close this. So set up Terraform, okay, simply installs Terraform using the HashiCorp Terraform existing action. Then we have initialize Terraform, simply runs Terraform init, okay? But on this Kubernetes staging directory, okay? And says input false, okay? So that we don't we don't have it stopping to take input from us because this is a CI environment. Then we have Terraform formatting, simply just to check that our Terraform config in Kubernetes staging has no errors, okay? Simple as that. Then we have validate Terraform. This is now where we do the validate, okay? the Terraform validate command. Okay. If there's any command here you don't understand, please let me know in the chat. Okay. But we have done these things so many times that I know people who have been following since the beginning know this. Okay. There's nothing new here. That's why it is good to repeat things. You end up mastering them. Then we have planning. Okay. So for plan, again, I check if the pull request, sorry, if the event name is pull request, okay, then I do the plan. Okay, I do Terraform plan. Then we have creating staging apply. I check if the event name is a push, if you've pushed, or if you've done an apply operation, meaning manually, you came here, okay, and clicked run workflow when the choice here is apply. Then we also do a Terraform plan, okay, and we have an output directory of the TF plan. Then we can now apply the staging infrastructure, okay. We say if the event name is push, or we did a manual operation of inputs dot operation which is apply, then we apply, okay. We don't expect any input to be taken from us. We approve the TF plan, okay. We approve that plan. Then we have another one here for destroying the infrastructure, okay, that you're going to see soon. Okay, so if github.event name is equals to workflow dispatch, okay, and inputs.operation is equals to destroy, then we do terraform destroy. Okay, so if you know what CHDIR means, simply means we are specifying the directory which has our Terraform configuration. Then we do destroy. We don't take any input from the user, and we approve. We automatically approve because this is a CI environment. Then finally, we come here, we set up kubectl. Okay, we check if the event name is push or apply. Okay, or it's a manual application. Then we use the kubectl. We use an existing action from Azure. After setting up kubectl, we then set up Helm. Okay, we install Helm. If the event name is a push, if you have done a git push, or if you have clicked apply on GitHub Actions. After setting up Helm, we go to the next one. Okay, we configure the Kubernetes, not the Kubernetes, but the kube config. We give it information about what the cluster and the region. We say if the event name is a push operation, or if the operation, sorry, the input operation is an apply, meaning we manually triggered it from our UI on GitHub Actions. Then we run a command. We say AWS EKS. Okay, so this one will be possible. AWS EKS, AWS CLI will be available because of the previous step here where we were setting up what AWS above. So we shall have update kube config. Okay, and what we are setting is the region and the cluster name, because you have to create the infrastructure for a particular region and it has to have a particular cluster name. We close that. So you see, it's quite simple. We go to the next one. Okay, here now we publish. Okay, again we check if we have pushed, okay, or we have clicked manually apply on the GitHub UI. Okay, this is where now we build the Redis endpoint, because this every time you destroy and create infrastructure, the Redis endpoint will change. Okay, from Elasticsearch. So we have a Redis endpoint being equals to Terraform. Okay, Terraform, we specify the directory of our Terraform manifests. Okay, then we say output. We want to pick output. Okay, and we want a raw output to give us the Redis primary endpoint. You get, this will give us our configuration, the endpoint for Redis. Then here we simply create a namespace. Okay, kubectl create namespace, and we give it this value. Okay, and dry run, meaning it will be happening on this, on the CI machine. Okay, dry run equals to client. If you want it to happen on the server, you say dry run equals to server. Okay, and then we output it in YAML and pipe its result to kubectl apply. Okay, for it to apply that command or apply the creation of that namespace. After that, using the same namespace, we say kubectl specify the namespace. This is the namespace. Okay, then we create the config map. You get, create a config map. using that name called infrastructure config map. And this is an environment variable mentioned up there. Okay, you'll see you saw it up there. Okay, then after creating it, we say it will be created from a retro, which will be Redis URL equals to Redis, okay, full colon, 2 forward slashes, Redis endpoint, then 6379. Okay. Then again, we do dry run equals to client minus o YAML, then we say kubectl apply. Again, dry run equals to client simply means we are running it on the CI machine. Okay. Then we output to YAML, okay, and send that YAML using this pipe to kubectl apply minus f. Okay, as simple as that. So this will apply and create the config map, having the infrastructure config map. That infrastructure config map is going to have the Redis URL that we shall need, that the backend pod will need. So I'll remove this. What else is done? Then we have, okay, installing Doppler. Okay, so we do the commands we did in the shell script. Okay, we add the Doppler repo, update it. Okay, then do a Helm upgrade, install the Doppler operator. Okay, as simple as that. So of course, like we did earlier, we specify the namespace. Then if it does not if it does not exist, you create a namespace, right? Specify the version and wait, okay, for a timeout of 5 minutes. Then we have configuring, okay, the Doppler authentication. Okay, so we have an env here, okay, which is can I say localized to this step, okay, and simply picks the Doppler staging token. Okay, so I created the token on Doppler and put it in the GitHub secrets, and I'm going to show you. I don't know if I can. This guy is now okay. All right, so you see our thing has passed. Okay, our infrastructure has been created. Let me deviate a little bit. So you see, all we have green ticks for everything. Okay, so it's been a success, which is good. So I can delete it, okay, and then deploy. Okay, let's deploy, then I'll continue explaining the workflow file. I can say gh workflow run deploy backend dash staging dot yml minus repo. I want to copy the repo name. Actually, should be up here. Sometimes I can act lazy just to avoid the repo. Will be that. Then minus ref is the main. Okay, made a mistake. Now I have to pay for it. I was supposed to say gh. Okay, like that. Okay, so you see the backend is not being deployed. If I go back here, okay, to the deploy backend, you see it has been triggered. Okay, it has been triggered. And you can see we're now on initialize containers. And we can also watch it from right here if you want, okay, using the same command. So I just need to copy the workflow ID here and say gh watch gh run watch, okay, the ID minus repo. Need to copy the repo again. Paste, then say minus ref. Really? Why is it saying unknown? Gh run watch the repo. Okay. Sorry, my bad. Exit status. It's actually my first time using the CLI command. But I have my notes here just in case I get lost. So you can see a number have gone on successfully. Okay. So now we are on deploy. Okay. We can wait for it as I complete going through this workflow fly. So for the name, configuring Doppler authentication, okay, we need a secret, a Doppler service secret. And I don't know if I'll be allowed to show you this time. Okay. Okay, this is still running. Let me leave it. Let me give it its space. So you can see that now we have a command, okay, that we run, and we create a namespace again, okay. Then we print some things, okay, but print and pipe it to another command of kubectl that creates, okay, a generic Doppler token secret, okay, from our standard input, okay, which is coming from this, and it will be called, we have this saying from file service token equals to dev stdin, which simply refers to standard input. And again, we're doing a dry run on the client, and then we pipe and say kubectl apply. Okay, as simple as that. So this is how we configure Doppler authentication. We're simply providing the Doppler token secret inside our cluster because it will be required, okay, for authentication. Then finally here, okay, says synchronize backend configuration, okay, where we simply, first of all, lint, okay, our Helm backend secrets chart, okay, that we discussed in the previous videos. After that, we do a Helm upgrade install to install that chart, okay, we install that chart, and we wait for it to be created, okay, we wait for the secret to be created. That's what you're saying for condition secrets.doppler.com.sync ready, okay, and look at this wait command, okay. I missed it, but I'm sure this is something we did and looked at in the past. That's why I don't want to rush through it. If you have any question, please let me know. Then after that, we have finally another wait. You see it here, okay, for another time, or with a timeout of 120 seconds. Yeah. So simply waiting for that secret to be created. So yeah, that's how we roll with this. Okay, so this is how we're going to create the infrastructure. So the next one, and actually I just put this here to let me know that this is a file that have changed in the past. Okay, but actually there's nothing need to change. I mean, there's no change in this file because I already pushed it. So I added that period at the bottom to help me easily identify them. So we're now done with creating the infrastructure. The next one is deploying. So deploying has the same things, okay? And actually, if I come to the terminal here, you can see that it has been deployed. Okay, it says run deploy back into EKS staging completed with success. If you go this side, okay, you see that everything has passed. Okay, we have proper success. Okay, in fact, if I go to the smoke test right here and I expand, okay, I zoom in a little bit, you see, says kubectl will run a command, okay, but the whole point was to hit the status endpoint, okay, and said status ready, which is something amazing. What else? So everything ran successfully, including the tests. So I'm going to show you in a moment. Let me just minimize this. Yeah, so I don't know how you do it, whether you'd have the same number of steps or reduce the steps. Okay, so let's go back to the side. Okay, so this is how you can watch from your CLI. So I'll put this down. So I know this is repetitive, so I'll not go through the things that I've already touched. Okay. So again, we have the name. Okay. So on all this, okay, it's the same like I mentioned earlier in the previous file, only that this time, okay, we are looking at different files, okay, and directories. So I'll leave this. Okay. So if you're maybe watching right now and this is your first time, okay, watch maybe the previous parts. So permissions, we have the same permissions, okay? Concurrency, just a different group, but the same thing. The env, yeah, this is just to enable us to build the image, okay? But these are not sensitive, okay? They're not things that we can like die, okay? If in case someone needs them, okay? The ones which are actually real are the AWS region, which is not a secret. The AWS staging deploy role ARN, okay? This one has to be created like we did in the previous video, okay? This was created, okay? So make sure you specify your own, okay? If you use mine, you don't have the credentials to mine, so it will fail for you, okay? The Python's path can remain, database can remain. This is secret, this is just to pass, okay? Just to pass the CI, okay? But the actual secrets will be injected by Doppler in the cluster. Okay, then we go to the jobs. Okay, we have a similar job. Okay, like the previous one. Okay, so we have a deploy. Okay, we have a test, build, and deploy. Name of the job. Okay, and applies on this repository only. So for those of you who are going to clone and copy this project, make sure you edit this to work for your project. Okay, so it runs on this machine, the bottom of this machine, and the environment is staging. Services, I needed Postgres, okay? Because we had tests which are running on an actual database, okay? So I'm using a Postgres database or image and a Postgres 16 image with environment variables for the username, the password, and the database name. And these are the ports, okay? The port mapping and having some options saying we have to wait for Postgres to be ready, okay? Wait for Postgres to be ready and we can check that it is ready on an interval of 5 seconds, okay? If it fails, okay, then we shall check every 5 seconds, but for every time we check, we wait for 5 seconds. This is the timeout. And then we retry a number of times, which is 10 times, as simple as that. So I'll close the services, then steps. Simple step like previously, we do a checkout, okay, to get our code. Then we set up UV, okay. This simply installs UV. After installing UV, we install our backend dependencies using UV sync, okay. Then after that, we run the tests, okay, using PyTest, okay. We run our tests. After running the tests, we now again using the AWS role to assume we configure AWS, then log in into ECR, okay, using an existing action, okay. After that, we resolve the image, okay. Let me reduce this, okay. I think this ECR registry is referring to this previous step here, okay. Previous step, we simply build an image repository, build the image URI, okay, echo them just for us to see them, okay. Then we check the image count, okay. Check the image count by performing simple query, okay. So you pass you say AWS ECR batch get image, okay. You specify the repository, the image ID, the query, okay, which is length, okay. And you see the output should be simply text. So we're trying to get the number of images, okay. And if the image count is equals to 1, then we say it exists. You get, okay. We say echo exists equals to true, and we pass it to a variable called GitHub output, okay. Else we say exists equals to false, and we pipe redirect it, okay, to a variable called GitHub output. Simple as that. So this stage simply helps us to check if we have an image existing or not, okay. So in this step here, okay, if the image does not exist, that is when we say docker build, okay, and tag it using steps.image.outputs.uri. Okay, I get this is now coming from the previous step above. Okay, and then we say backend. Okay, so we build an image only when it does not exist. After that, we have push. Also, we only push, we do a Docker push when the image does not exist. After that, kubectl, okay, simply set up kubectl, set up Helm, okay, install Helm, okay. Then we now configure the kubeconfig. We tell kubeconfig that we are going to use this region and we're going to use this cluster. Simple stuff what we've been doing, okay, but only now it is in a CI. Then you say verify Doppler managed secret, okay. We simply wait, okay. That in this namespace, we want to wait for the creation of a secret called backend secret. Why? Because we need it for the migration and for our API and worker. Then you come here. Here we simply do a Helm lint. Okay, I've explained Helm lint 1,000 times in this playlist. I'll not go through it. So we simply lint. Okay, then we do a Helm template. Okay, by now I expect everyone who has been following to know what Helm template does. Then after that, we now deploy the backend, okay, by using a Helm upgrade install, okay, and we have done this also 1,000 times in this playlist. So I expect you to understand this. However, if you don't, leave a comment for me. Then after deploying, okay, we can come here. So the step for debugging is here, okay? In case the previous step failed, okay, then I have some statements using kubectl to help me simply find out what the issue is, okay? For example, here I say kubectl, okay, for this particular namespace, I get the deployments and pods, okay, just to see what the pods which have been created, okay? Then here I describe the deployment to get more information about it. Then here I describe the pods, as simple as that, okay? Then after that, I also look at the logs. So usual steps, okay? You find out the pods and deployments you have. Find out more information about your deployment, okay? Find out more information about your pods, you get? Then you can now go and look at the actual logs, okay? So selector simply selects is a label, okay, for your pods or your deployments, okay? Yeah. Then after that, okay, we simply describe also the job, okay? Describe the job, get pods for the job, okay, and get its logs. As simple as that, okay? That's what we are doing. See the pod names and the pod names, deployment names for the API and worker or the job, okay? Get more information using describe, then see the logs. And these are just options to give you more fine-tuned output. Then again, we can do get events, okay? And you see me saying sort by last timestamp. So this is what I was using for debugging when things were failing, and it's a good step you can have. Then we verify rollouts, okay, by saying kubectl rollout status, okay. I expect that you know this part here. I simply specifying the namespace. So we check the rollout status in that namespace, okay, of this deployment, and simply add the simple timeout. Then again, we have the same thing. We check the rollout status for the worker. Okay, so we check the rollout status for both the API and the worker. So the same things we've been doing in the terminal is just being done in the CI, okay, for us. Then after that, we do the smoke test, okay, just to find that our things are working, okay. So if you look at it carefully, again, we do a kubectl command, specify the namespace, okay. Then we do a port forwarding, okay, for our service, okay, to these ports, okay, from 8080, from 8,000 to 80, okay, as simple as that. And we pipe that to a file, okay, as simple as that. Then we trap, okay, say trap kill on that port, okay, and say exit. Then here we just do a for loop and do a number of things, okay? But this for loop is simply, the goal here is to hit the live endpoint. Isn't this live endpoint? Yeah, we simply hit this live endpoint. And also, if you go down here, we hit the ready endpoint. As simple as that. Using curl. Okay, so you can see we're saying if curl minus minus fail minus minus silent. Okay, then they specify the URL and we push the output to the dev null. Okay, yeah. So this is just a if statement in shell. Okay, so if so to end an if statement in shell, you say fi. Okay? Yeah, it was crazy to me the first time when I learned shell or Linux, but yeah, that's how you do it. Yeah, so the same thing here. Okay, here we're just doing a cut on this file. Okay, having our log. So the cut simply helps us to see the context of the file. Yeah, see the context of the file. And if you look at up here, like I told you, we are piping the result of this kubectl pod forward, okay, to this file here. You get as simple as that. And then we access it down here, okay? Yeah, for the for loop is actually easy. We're saying for attempt in from 1, this is like doing a range in Python, okay, from 1 to 30. We get from 1 to 30. Then we wait down here for the 30th attempt. You get as simple as that. So when we are done, yeah, we simply maybe put a delay, simply doing a delay of 2 seconds, and then we say done, and then yeah, finally we output something. Okay, so that's how you do your smoke test. Actually, if you go to the CI here and go to the smoke test here, you can see the actual command which was run. Okay, the same things we run. Are you seeing this? Everything is the same. You get, yeah. And of course, finally we see our status being ready. So I didn't want to show you everything because it might leak a secret, which I don't want to do. All right, so yeah, this is how you do it. And again, I'll remove this last line. I need it as a marker just to let me know about files which have changed. So, yep, that is expected. Then a few more things here in the values.yaml. Okay, I simply added this existing config name. Okay, that we used that I showed you in the what's it called, in the infrastructure. Well, my mind is tired. In the infrastructure of, sorry, I meant to say is what I showed you in the what is it called, the workflow file for creating the infrastructure. Yeah, so then value staging here also has the same thing. Okay, yeah, so I'll remove this last line. I just put them as markers to let me know about the file I've changed. So I think that's all. Maybe templates also has a change. What did I change here if I remember? Oh yeah, so here now you see that apart from the secret ref, okay, now we have a Redis URL which is coming from a config map key ref. You get, yeah, that's the only change I added here, and that is built in the CI. So you can actually replicate this, or duplicate it and create your production infrastructure by simply editing values, okay, in your values.yaml, or even dynamically at runtime. Then here, let me see, what else did I change? Yeah, right here, the same thing here, okay? So we have the secret ref, then we have the config map. Yeah, so I'll remove this too, so that I have a clean CI, okay? So once you push, everything will be triggered, okay? So try it out. And I have another thing I wanted to show you. So I want to show you how did this trigger happens, okay? Because I did it in the CLI, but now I want to do it also here. So I'll come here and I choose destroy, okay? Then click run workflow, okay? So you're going to see it's going to destroy it because I don't want to spend on it for now. So I'm destroying it. Then here we can watch it, okay? If we want. Yeah. Now, as it's being destroyed, I'll open this in a new tab. What is this? Okay, I can close this. So if you look at the infrastructure here, okay, are you seeing it says active? Okay, it was created, but it's going to be destroyed. So earlier on, I showed you when the status was creating, and now it is active. So I expect it to be destroyed soon. So can come here. Okay, so yeah, the destroying step is now happening. But I wanted to show you some secrets, okay, that I've been talking about that you need to add. So secrets and variables, actions. Okay. So are you seeing this? Doppler staging token. Okay, 5 days ago, and Doppler token. Okay, the rest are all GH patches 3 months ago, KPNM 6 months, SSH 6 months. Hey, I even don't think I need SSH anymore. Hey, I need it, sorry, I need it for the compose deployment. But this, okay, I put these two, okay, just to make sure that I'm not using one Doppler service token for the same environment to avoid issues, okay? So this one will be particularly for the staging environment. This one will be for the EC2 compose production environment, okay? In fact, I'm going to create another one. In fact, for local development, you simply create it locally using that export command. So yeah, this is what I wanted to show you. Make sure you separate this. With this, I think, yeah, you can create, once you understand the things, you can create your CIs in a powerful way. So I guess I can close this. Yeah, this one is still destroying. If I come here, refresh. Okay, still active. But I think destroying actually is way faster than the process of creating. So yeah, you can see our deploy. Our deploy watch was quite successful. It went through a number of steps. Set up the job, initialize containers, check out repo, set up POV, install dependencies, run backend tests, configure AWS credentials, log into Amazon, resolve the backend, build the backend, push, set up kubectl, set up Helm, configure staging kubectl config, verify Doppler managed secret, validate backend Helm chart, destroy backend with Helm, diagnose for the deployment. This one did not run because nothing failed. Okay, but this one can help you to debug in case things are bad. Verify backend rollout, smoke test backend, post login to Amazon ACR, post configure staging AWS credentials, post setup UV, post checkout repository, stop containers, complete job. Quite a lot, right? Yeah, so this is taking time. When I wait for it to succeed. So if you're enjoying this, please leave a like. Let me see. What can I do here? Is this what I want? Okay. I want to see if the status has changed on EKS. Okay, not yet. And actually, destroying using Terraform is much better because it gets to destroy every resource. But sometimes if you destroy from the UI, you may destroy not knowing you have actually left out some some resources, maybe an EBS volume or a node it had created. It can be some pain when you're being charged. Yeah, so let's wait for it. So still active. What's this? Control plane. Yeah, by the Amazon charges I think $74 for the control plane. So if it is something you can excuse me, if it's something you can handle, if it's an expense you can manage, you can go for the $74 per month. But for me, for now at the beginning, I want to stick to Compose. In fact, there's a solution I was looking at recently that I would want to migrate to. Okay. 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 So it's still destroying. Did you give us an idea up here? Okay. Yeah, so this is the whole thing. Okay. Yeah. So you see some things were skipped, okay? Planning was skipped, code staging apply was skipped, applying staging was skipped because of the if statements that we have in our file. Yeah. So I guess now you get to see how long it takes to actually destroy infra. Because you have nodes. Okay, I think we had two nodes. We have two nodes. We have what else? Two nodes, a control plane, the auto mode. We have the elastic catch. Okay, we have trust policies. I think 3 trust policies, 3 roles, a number of permission policies for those roles. So yeah, they all take some time. Wow. So, let me see. The status changed. This is what I was looking for. So you can see it has changed to deleting. We're moving. We're moving. Okay. Finally. So that step was successful. So we are done. You see? So look at this. If I go up, okay. Like I told you, I think says AKS AWS EKS cluster staging destruction complete after 3 minutes 45 seconds. That is how long it took. You get. So like I was telling you, see, we had a role policy attachments to be deleted, number of policies, okay. Then node being destroyed, okay. The cluster, then node. Says destroy completed, 19 resources destroyed. So when you just come here to this one, okay, and you click delete using this delete button, you may not be able to delete the 19 resources which were created, and then you'll struggle with expenses and costs and wondering what is happening. Okay, so if I refresh here, you see we don't have any clusters. This is what I wanted, so I can sleep in peace today. So you see we skipped so many things. All these were skipped. Okay, then everything is okay. Okay, our job was completed successfully. Yeah, so we're getting to the end of this. Getting to the end of this. Maybe the next two shall be done. Then we switch to other concepts in AI agent system design, microservices. Then when I'm done with AI agents, that's when I'll get back to build the AI agent for this project. So I guess, yeah, wait for 2 more live streams on this, then more videos, then we can wrap it up. But I've liked it. It's been a good learning experience. I've learned quite a lot. I've mastered quite a lot, and yeah, it's been fun. Talk soon. Bye for now.